So yesterday we saw how to ingest data. We ingested the data, but after ingesting the data, a subfolder, a subdirectory was created in the table directory. And as I said that Hive does not understand any subdirectory inside the table directory. So to make it understand, so we have to make sure that that subdirectory is the partition directory for the Hive. So to do that, we created the partition. We executed the command add partition. So this part was over. Add partition to Hive table. So we have our data in Hive now in the raw database, and inside omnichar table and sales table. Next, what we will do is we will prepare omnichar data. So omnichar data is nothing but the clicks data. Preparing here means we will sessionize that. We have already seen the sessionization. We'll sessionize, then we'll also adjust timestamp to 2017 because our data is not related. That's the reason we are doing this. So let's see how it looks like. So if you open the e-commerce marketing pipeline, so there we have a jobs folder. There we have jobs folder. So if you go to the jobs folder, so we have our map session. It's not map session, prepare omnichar data. So this is one job. So how we have created our job here. So this is our prepare omnichar data. As you can see here, we are extending it from a Spark job. Now Spark job is an abstract class. So if you open the Spark job, which is here itself, if you go and open the Spark job, it is a abstract class where we are setting the configurations parameters. We are creating our Spark con. We are creating Spark context. We are creating SQL context, Hive context, and configuration information. So all these things are created here so that we don't have to create it again and again for every job. So we are just making sure that we create it once and keep it in one class so that it could be used for other jobs as well. So that's the reason we are making it as an abstract class. Every job should have this. Hence we have making it as an abstract class. Conf object, Spark context, SQL context, Hive context. Hive context is nothing but if Spark wants to access Hive table, Hive metastore, Hive user defined functions, so it has to create Hive context. SQL context does not have the capability to connect to the Hive metastore, use Hive user defined functions, Hive aggregate functions, and anything related to Hive. So SQL context does not have the ability to do that, but Hive context can do. So just to give an idea, Hive context is also similar to SQL context but has more capabilities. So you can think of Hive context is a superset of SQL context. So whatever SQL context can do, all those things we can do with the Hive context. Like we can use the data source API, Hive context dot read dot format dot all those data source API that we use with the SQL context can be used with Hive context. Plus, it can connect to Hive related stuff. Hive Metastore, Hive user defined functions can also exist. So just think of it as a superset of Hive Spark SQL context. So let's go back to our prepare omnichar data. So we have that's the reason we have extended it the Spark job. Our prepare omnichar data will extend the Spark job, and then we pass on some configurations parameter. So the configurations parameter is also defined using Scala's config object. So this is our Scala config object. Sorry, I mean to say the parser that we are using. This scoop parser is a generic parser used for parsing any arguments. So it is a library. So any library could be used. This is mostly used scooped parser. Probably most of the companies use this scooped parser to parse the input arguments. The input arguments, whatever we can give is we can give what is the date we want to pick the data from where we want to pick the data from. Like we want to pick the data from processed sales table or processed omnichar table or raw sales table, raw omnichar table. So those are the options that we are passing here. So this is the normal parser, a simple parser, and we have some default parameters. So default values are all kept in this config class. All the default values. So raw sales data path is this. Raw sales table, processed sales table. It's there in the processed DB and sales table. Raw omnichar table, just the default values. We can change it by passing some arguments. If you want to pass different table name, you can. Different if you have some different table path, you can pass that as well. So these are all the configuration related informations. So let's again go back to. So here, as of now, the only parameter we are passing is the date, because this has to pick the data from a particular date, and the date is our date R timestamp. So date R is our partition. So this Spark application, this Spark program has to read only a particular R's data. So that's what we will be passing here, and it will store it in after parsing that argument, it will update the conf object. So this conf will have our current date that we want to read the data from. Current date R, it wants to read the data from. And again, we have some utility classes. Raw data reader class we have. If you see here, some utility classes we have. Raw data reader. So there we have multiple methods written. So we have read omnichar method. Read omnichar, like you can read the omnichar data just by giving the path. By giving the path, you can read the omnichar data by accessing through the Hive table. by accessing through the Hive table. Because what we have here is, we know that when we say Hive, data is in HDFS, metadata is in MySQL. When I say metadata, the table information, actual table is created in the MySQL, and data is in HDFS. So now if I want to, Spark wants to read the data from Hive, what all option does it have to read the data from Hive? Since the data exists in HDFS, you can directly give the path of this path of the directory, and Spark will read this. Spark will read through the path. Or what is the other way it can read? So it can connect to the Metastore MySQL database, and it can read the data. I mean, in this Metastore, in this MySQL, it will also have the location of the data. So using that location, metadata also contains location. Using that location, it can read the data. So just to showcase, probably most of the people know that. It use the raw database. So if we say show tables, these are the tables we have. Let me describe formatted sales. It gives you the details or metadata of the sales table. So if you see, so from the metadata, there is also a location field which says where this table, to which directory this table has been mapped to. This table has been mapped to this data stored in this folder. So what I'm trying to say here is, if we connect to the Metastore, which is in case our MySQL, from there it will get the a location field, and using that location field, it will start reading the data from HDFS. So you don't have to explicitly specify the path. I mean, Spark has two different options to read the data from Hive. One is through directly you explicitly provide the path, or it will connect to the Metastore, get the path from there, and read the data from the Hive. So we have two different methods defined for that purpose. So this read omnichar, we are explicitly giving the path. So one more method we have defined, read omnichar Hive, where we use the Hive metastore, or we just specify the Hive table. It will get the table internally. It will get all the details of that table and read the data from there. So read sales we have, similarly read sales Hive. So here we directly give the path. Here we use the table name to read the data. So let's go back to our main program again. Prepare omnichar data. So here we are using a read omnichar Hive. Read omnichar Hive, meaning we have to specify the table name here. we have to specify the table name, and table name we are giving it from our conf object. So if you go and check the raw omnichar Hive table name, so it will be raw dot omnichar. So we have to just specify the table name to read the data from the Hive. So if you see our read omnichar Hive method, you see that. So we just use Hive context there. This Hive context is already created. It's already created. We say Hive context dot table. You don't have to use the data source API. You don't have to use the data source API. Data source API only comes into picture if you have the path. If you have the path. I mean internally it will take care. When we say table, it will connect to the meta store. It will first internally it will connect to the meta store, get this table's information, whatever table we are saying. From that table, it will get the location information, and using that location information, it will start reading the data. Now how it will connect to the database? It needs to know where the MySQL server is running. It needs to know where the MySQL server is running. That's the reason we have put everything inside our Spark Spark job abstract class. So if you see here, so this takes care of setting the JDBC driver, the IP address and the port on which MySQL server will be running. By default, it will be running on 3306, and this is our IP address. What is the table name? Sorry, what is the database name for our metastore? Our JDBC driver, username and password for our MySQL database. So these properties has to be set to make sure that our Spark can connect to our MySQL database. So it will, because of this, it will be able to connect to MySQL database. And we need to also have the MySQL driver. So you need to add those things into your form.xml. Also that scoop, the parser, the program argument parser library also has to be added to your form.xml. Similarly, MySQL driver should also be added. Do you see MySQL here somewhere? Connector is not there. Let's see. I think I have added to the downloaded the jar and added here itself. So I go to the project structure. From the file tab, if you go to the project structure, there if you go to modules, inside modules, if you go to dependencies, I think I have added here itself. Otherwise, it will give a error. Okay. I can add it here. Let's see whether it gives an error or not. Let's see whether it gives an error or not. So we did all the requirement. I mean, we haven't seen the logic yet, but all these things are required. We have to, so utility methods I have shown here. So this will read the data, but we are specifying the table here. So in the table on an hourly basis, lot of subdirectory will be created. So we know that inside the table for each hour of the day, multiple subdirectories will be created. So which subdirectory it has to read, which partition it has to read in fact. So that we are specifying here. We are just saying Hive context dot table name. Then we are saying filter where date ts is equal to our configuration date ts. We will be passing this as a program argument. But in case of automation, it will be coming from Oozie. In case of automation, this date information will be coming from Oozie. For every a different hour of the day, a different date will be coming from the Oozie. Now in this case, we have to explicitly pass this because we have to test it. And it will read only the data from that partition. So once we have that data, once we have this data, so here we are just trying to bring this I'm hard coding so that we can bring it to 2017. We can bring the timestamp to 2017. So here with column is a method on a data frame which adds a new column. With column will add a new column. Our new column name is ts. Column name is ts, and the value for that column will come from here. So we already have a column with ts, I think. Let's check our omnichar. Let's check our omnichar. So if we see the omnichar, we already have a column name by timestamp. So we'll just overwrite that column name. We are overwriting that column name. The values of that column will be new values with the 2017 timestamp. So this is the existing timestamp. This is some hard coded value. It will add this much. If we add this much of value to your current timestamp, it will bring the timestamp to 2017. We will see that. First we'll just see. I will just select the star from omnichar limit 10. So as of now, the timestamp as you can see is 2015 some timestamp. This is our timestamp to which we are adding some hard coded value. So that hard coded value will give you will convert this timestamp to 2017. And lit is a function. Lit is a function defined inside the Spark SQL. I mean, you just cannot pass a value. You just cannot give a value. That value has to convert it into a literal. So this will convert into a Spark literal. So usually we say 10 as a literal, but in case of Spark, we have to explicitly do that. You cannot just say normal value. Spark does not understand a normal value. It has to be converted into a actual literal. So there is a function that takes a normal integer and converts into a integer literal of Spark. So this is the column name, and this is the value for that column name. After that I'm dropping the date underscore ts. So this we are dropping. This column I am dropping. So if you see this column, This column gives you whatever the subdirectory name it is. The column name is nothing but the subdirectory name. Underscore 8 was our our R of the day that yesterday we created. We are dropping this. There is a reason why we are dropping this. I will explain this later. Later we'll add it again. This column will be added again, but there is a reason. I will explain that later, because we need this. We need this data because again we have to write the data to the processed database with the same date time, with the same hour of the day. So this takes care of adjusting the timestamp, and this takes care of our sessionization. This takes care of our sessionization. Here we also have a window operation. Here we also have a window operation. So what is a window operation here? So to understand window operation, what we have to do here is, as of now window operation is not required. I will come to this window operation. I will come to this window operation. Let's ignore this as of now. The only thing that we have to do is this: mine sessions dot mine session from source. We pass our data frame. This is the new data frame we got, where we have added the timestamp. Yeah, here is a question. The question is to explain the literal function. I mean, Spark, you cannot add a value. Let's say you have a data frame. You have a data frame called, you have name, you have age. Alice, Steve, Bob, 40, Mike, 30, Sam, 20 something. So we have this age and name. Now I want one more data frame. I want to have city as well. So I want to add city, name, age, then we have want to add city as well. So the way you can do here is, this is our df. So you can do df dot with column. I can say with column city. It will add a new column called city, and you can add some value, some random string we will say. Let's say there is some function which will return a string, which will return the random city. It will return a string actually. So you call some function here, random city, it will return a string, city string. But you cannot just pass a string here. You cannot pass a string here. It has to be converted into a Spark related string. So literal is being used here. So instead of, you cannot directly have this will return a string. You directly cannot pass a string. Instead, you have to convert into a literal and then include it in the table. So literal, any basic data types that you want to add as a value to your column, always it has to be wrapped as a literal. Always it has to be wrapped as a literal. So I hope Pragati, that was clear. So that's what we are doing here. Here this gives you some a integer. You cannot just make this integer as part of the column value. It has to be converted into a literal value. So just forget this session window operation. It is actually optional. So we have to just do our sessionization. So this method takes our data frame to which a new session ID will be added. So we have seen this example. This piece of code we have already seen, where we are having where we are doing custom partitioning, where we are doing repartitioning and secondary sorting, and we are also using map partition higher order function to do the sessionization, and here we are adding our new field, and here we are adding our new. So we should have a session ID. I'm not going to explain again the sessionization because we have already seen. So we got our session ID. So just to showcase how the things look like, what we'll do is I will try to comment other things. We'll just run one by one here. Some things are, so you can run in this fashion. You can comment few things and you can run. So it will only show the data that has been read and the timestamp has been modified. So as of now, you can see that the timestamp is 2015. But after we add, it will be in the numerical form, long integer, not in the date timestamp. So let's run this. So before we run this, let's see what is the input parameter we should use here. Yeah, this is the input parameter we have to give. Hyphen hyphen date. This is how the scooped parser will work. This is how the scooped parser will work. It will look for hyphen hyphen date ts and the value for that where we want to read it. So in our case, what is the subdirectory here? Subdirectory will be this 2018-04-25-08. That's our subdirectory. That's what we have to specify. So it will only read from that partition. It's only slower because of the IntelliJ, otherwise it will be faster. So as we can see here now, I'm just showing the details. So we have read the data from Hive table. So to read the data from Hive table, we need the metastore information. All the metastore information we have given, where the MySQL server is running, what is the database name in the MySQL server, what is the username and password for MySQL server, and the driver. Somewhere I think driver I might be using, I don't remember. Otherwise it should have failed. So the timestamp has been changed now. The timestamp has been changed. So now this is the 2017 timestamp. So we adjusted the timestamp. Next we'll again run this once again. So we see that sessionization will be created. So this will have the sessionization. So also there is a this actually is not required. Actually is not required as of now to get the min timestamp and the max timestamp of our sessionization. So as of now, what we have our clicks data, right? Clicks data frame, or we will say omnichar data frame. So we have multiple columns. I will just say column 1, column 2, column 3, so on, which is timestamp, uh, URL, URL, all those things we have, or we can write it as it is. We have timestamp, we have URL, we have user ID. So these are all the fields we have. With sessionization, one more will be added called session ID. Now this will be the new column that will be added after doing the sessionization. It will be some random unique number, unique ID. Some unique ID will be the value for this session ID. So again we are adding one more column, session duration. This is as of now not required. Session duration. The session duration, what it will see is, I mean, when was the minimum, what was the starting time minus the end time. A session ID will have its starting time and the end time. So this was at 6 o'clock, 6:05, 6:15, 6:20. These are all one session ID. So it will be session 1, session 1, session 1, session 1. So we will minimum is start time is this, end time is this. So the session, let's say after that we have 7:20. So obviously this will be different session because there is a time difference of more than 30 minutes. So this will be session 2. Again we have 21, 23 something. All these will be session 2. So each session will have a start time and an end time. So difference is nothing but our session duration. As of now, it is not required. So session duration will be 20 minutes. Similarly for this also we will have session duration. So as of now it is not required for us, but still we are computing so that it could be used later. Don't worry about that. So that session duration column, we are just computing max minus min, max minus the min times. Using the window operation, we will see the window operation later. So let's run this and showcase how the omnichar session ID looks like. One more column will get added now. two more columns, session ID and session duration. So we will see the result here. So as usual, all the fields exist. Along with the field, now two more fields are also added. Session ID, session duration. Session ID and the session duration. So as I said, we will be creating a unique ID for each session. So all these belongs to one session, as you can see. Again the session ended here. The session ended here. A new session, probably for a new user. So there was only one click from that user, hence there is not much session IDs. Again, multiple clicks from that user, so same session ID here. So this is what we have added, session ID and the session duration. What is the start time, difference between the start time and the end time. It comes to around 661 seconds or minutes. I think so. And finally, we are adding back our date TS. Earlier we had dropped this column. We had dropped this column. Now we are adding back that column. There is a reason. So that column should be always the last column. That's the reason I already earlier we deleted that column, and again we are adding this column here with column date ts. Earlier we had dropped that column because in between we are adding two more columns, session ID and session duration. So that's the reason we had to drop it, so that it should be always the last column. The reason behind that is when you insert the data into Hive, when you insert the data into Hive, and if that into Hive table, and if that table is partitioned by a column, so that column should always be the last column in your data frame. I mean, our goal is now to put this data frame, save this data frame to Hive. Our goal is to, this is our processed omnichar data now. This is our processed omnichar data. Now we have to put this processed omnichar data to the processed DB in Hive. So whenever we have to create a table inside our Hive processed DB, and into that table we have to insert the data from this data frame. Now our table will be partitioned by again date ts. Our table will be again partitioned by date ts. So whenever we have a partitioned table and we are inserting the data into that table, so our data frame should have the column name as the partition column as the last column. So that we have to keep in mind. So that's the reason I dropped it and again I added it back. Otherwise, session duration would have been the last column. So I will think that this will be the partition column. This will be the partition column. Now how do we add this? So some hard coded values are here. This has to be fine tuned. So this fine tuning actually I have done in other project. Like if you remember, I asked Oot data analytics. I mean, change the remove the special characters, rename it to new columns and save it somewhere. So there I have removed all these hard coded things, and done it in a proper manner. That code you can copy it here. I will share that code as well. So here what we are doing, once we have a data frame, we are registering it as a temp table, register it as a temp table, give a table name for our data frame, then select the data from this table and insert the data into Hive table. It is just like in this fashion. In MySQL, just think of your MySQL. You have MySQL table 1 and you have table. Suppose you want to insert the data into table 2 from table 1. So what you will do is you will select from table 1 and insert into table 2. I mean, there is something command like this. Insert into table 2 by selecting the fields from table 1. The same way we are trying to do here. Our table is omnichar. Our table is a omnichar, which is our Spark. It is a Spark data frame, and the data frame name, the table name that we have given is omnichar. In Hive, we will create inside the processed DB. Inside the processed DB, we'll create omnichar table. And we select the fields from this omnichar table Omniture data frame, from this Omniture data frame, and insert into this. I mean, we read the data from our raw database and insert into the processed database. We do some processing on that. We adjust the timestamp. We do sessionization, and then we insert into the processed DB Omniture table. This is what next piece of code is all about. Now, how do we insert the data? So how do we create the table here? So first we have to create a table. When we create a table, we have to specify columns. What will be the column names here? How do we know the column names? So the column names should be same as our data frame column names, because you cannot just, I mean, how do we know any column name? Because our all the column names are in our data frame. So we have to get the column names from our data frame and prepare your create table command. So create table command has to be created, and the column names must come from Omniture data frame. Omniture data frame column name should come from. So how do I get the column names? So here is the things that we are doing. All these things you can put it in one function. That's what I was trying to say. I'm just putting it in the same main method. You can define a different function, and in that function you can put all those. So this is our data frame. Data frame dot schema will give you the struct type. Schema dot fields will give you an array of your schema struct fields. So if you see here fields will be array of a struct field. Field is nothing but array of struct. So from that you need to create your select. I mean to say a create statement. So what all columns are required? So struct field is a class. Struct field is a class. We know that it has three members which are important. Struct field, we know that. Struct field class we have. So which has three fields: name type, and nullable. So if you remember, we used to give the name here, type, and true or false here. So from the struct field, you get this name. So you get the column name. You get the type. You will get the type. Nullable could also be extracted. So you can do all those stuffs. So that's what we are doing here using a for expression. We are doing that. Go through each field in this array, and we are just ignoring the date ts. There is a reason. This date ts field we are ignoring. So whenever you create a table, and if you partition by some column, that column name should not be specified while creating the table. So what I'm trying to say here is that is all Hive related details. If you see that HQL, here we are creating the table. So here if you see, we are creating the table sales. and we are saying partition by date column, date TS column. So when we say partition by date TS column, the date TS column should not be specified in here. It is implicitly taken care that date TS is also one of the column. It is implicitly taken care by Hive. We don't have to specify. So now we have to create our own table. So we have to create our own table, and date TS should not be part of this create statement. It should not be used here. So that's the reason we are skipping that date TS and creating a string. Field name, column name will give some space, column type, and then comma. So usually that's how our create statement will be, right? How will our create statement will be? Create table omnichar. We will say column name is ts timestamp. Column type is probably some string. Then we have comma. URL string comma. So we are creating this part here. We are just building a string in this form. We are just building a string in this form. This will come from the struct field name, struct field type, and then we are doing the comma. So we are extracting those fields: name, space, type. Now the type in Spark is not same as type in Hive. So again, I have created a hash map, because in Spark we have long data type, but in Hive we say big int data type. There is no long data type in Hive. You cannot give a column data type as long. So there it is big int. It will fail to create the table if the data type does not match. So I'm just converting from Hive Spark to Hive type. We take the data type, name, and if it is a string, it returns, because Spark Hive also supports string. If it sees it is a long, it will return big int. And then we have our comma. It will be done for everything. All the columns it will be done. So that's how it looks like. Now then we use create table. Create table if not exist. What is the table name? Table name again we get from the conf object, which is processed omnichar Hive, which is nothing but in the process DB will be creating the omnichar table. In the process DB will be creating omnichar table, create table, and the fields will come from there. Field string is nothing but the string, which will have the column names and their corresponding data type. Here just we are saying substring -1, because last comma should be ignored. Every time we'll be adding a comma, that last comma should be ignored. So that's the reason we are saying -1. And we just say again partition by date ts. Partition by date ts and store the data as a Parquet file format. Our normal data was a CSV data. Our data was a CSV data. Now we are creating the table. We are creating the table as a Parquet file format. So your data will be converted from a CSV file to, because Parquet is much more optimized file format. And this table is also partitioned by date string. So we just run that query using the Hive context and SQL, where we used to give SQL query. Here we are giving our create statement query. So this will create our table in the omniture. Once we have the table, we have to load the data from our data frame. From our data frame, we have to insert the data to this table. That's what we are doing. Insert into table, which is new now created table. Insert into this table, which is partitioned by date ts. Select the data from our data frame. Select the data from data frame, because that's the reason we have registered it as a temp table, so that we can select, we can give SQL query and select the data from this data frame table and insert into Hive table. So we have our query here, we have query here, and we insert into the, we run this query using same Hive context of what you can do is these two things, this whole things could be put in different functions. This whole things could be put in different functions, because for every job we have to write this piece of code. In some other project I have done that. This I didn't get the time to revisit this in the project where I have done sample app. Yeah, as you can see, I have just written some methods, and everything it is put inside this. Create table from data frame and insert into table. So instead of writing in this fashion, instead of writing all this, put all those things in different function, creating of the table in one function, inserting data into another function. That's what I have done here. So this I will share. I mean, this is the same code which I have given the exercise, So it will create the table from the data frame. Again, I'm using internal function, so which will create the string, create table from data frame, and insert. One more is insert into. Again we are doing that, so that you can just call this method. You need not write the code every time. If time permits, I will explain that as well. But we can always go through that. Which project? So if you want to go through that, it is there in Spark 2 experiments. It is there in Spark 2 experiments. Here is a question. The question is any work example that work for complex data types. Now, what do we mean by complex data types here, Anand?
Let's say if we are building a table from a data frame, and if this data frame is having a complex data type, let's say a map or struct data types.
Okay.
So
So the each column is a different data type. Each column is a complex data type. Could be a map column, Okay, I don't
Yes,
have an example for that, but it could be created. It could be.
I'm actually having one requirement right now in my project. I mean, it is the exact requirement. We'll be loading a base table into a data frame, but that base table is having complex data types, and we converted that into a complex data type data frame. And when I try to write that in a Parquet format into HDFS space, I'm getting some errors saying like the schema cannot be write exactly as how I read.
Okay,
So that's why
okay,
I'm asking this particular question.
okay. Let me do some examples because I have some data with complex data type. I will try to showcase that example. So I have some ELP data, and ELP data is a bit of a complex data type. Let me test it and showcase. And if you want to see this, those methods, we can go through this loop blob and save to Hive version 2 code it is. So it is there in the Spark 2 examples. Inside that, in the testing folder. If you go to the testing folder, inside the testing folder, you will see sample app. Inside that sample app, you will see the loop blob and save to Hive. This is actually the exercise that I had asked. The same exercise code is here. Now coming back to this, so we created the table and we will insert the data into the table. So
And
let's
Pramod, I think this latest one is not in the image actually.
which one?
Loop. Just now you showed right in testing sample app.
Oh,
So I'm not seeing that. Yeah.
oh, this is there.
No, no, this is not there. That is what loop, blob, and save to Hive v2.
Oh, okay, okay. I will share this code. This code should be good enough. I will share this.
Oh, yeah.
I think I developed this after creating the image. Again, it will take a lot of time to create the image. And again, I have to upload 9 GB of the image once again. I will just share this piece of code. This code should be good enough. So let's run this program and check the result. So we'll just insert the data into the Hive table. So we'll remove all this show here. So this will create a table in Hive, and also it will insert the table, insert the data to that Hive table. So if you go back and check in your beeline, so if we say use processed DB, this DB we already created during the initial step. So if you say show tables there, as of now nothing is there inside the table. So our Spark program will create a table called omnichar and it will insert the data omnichar, and a partition will be created because this table is also partitioned. A subdirectory with the same partition name will be created. we can also check the HDFS as well. HDFS is not up and running. It is done. It has exited with code 0, meaning it should successfully executed the code. So let's check in our from our Hive. Let's check whether a table has been created here or not. So again we'll say show tables. So as you can see this time we got our omniture table created. So if I say describe formatted omniture, so it will give the details. What are all the column names? Timestamp column, IP column, URL, user ID, city, country, state, session ID, session duration. The same columns that were there for the data frame are created here. And location, as you can see now, it will be in the processed DB. This DB was already created, and inside that a omniture folder. Whenever you create a table, a omniture table will be a directory will be created, and it should also give the partition information. Do we see any partition here? It doesn't say anything here. Date ts is the partition information. Date ts is the partition. So a subdirectory will be created within this directory. So HDFS web browser, I don't know why it is not showing. Yeah, it has come here. Browse. User Hive warehouse. Inside process DB, we have this omniture table got created. So there a subdirectory has been created by this date underscore ts equal to the date time. So as and as you every time you run this program, every hour you run this program, a new folder will be created by this name. Underscore 9 will be the next hours, underscore 10, underscore 11, underscore 12, and so on. New directories will be created for each hour of the day. So this partition has been already added now. So if you query on this now, I'm querying the data has been written by the Spark into Hive, and we are querying it from the Hive itself. Select start from process dot omniture. I'll just limit it by 10. So we get our data. Timestamp, IP address, URL, user ID, I think city, country, state something. Then session ID has been added, as you can see, and we also have the session duration. So that's how we are creating our processed data. So what we did is Spark job prepare omniture. This just to showcase the ETL purpose. So we have our raw data, raw DB. From there we had our omniture table. So data was read from here. Sessionization was done. Timestamp adjustment was done, and it was saved to processed DB. It was saved to processed DB. There also we created the table. So this is our Spark job 1. I hope the Spark job 1 was clear. Prior to that, we did the add partition job. Add partition was one more job. So we'll be having our sales table. The sales table will be read by our Spark job. Second Spark job will be running. As soon as this first job finishes, I will be running it manually here, but when we see in automation, as soon as the first job finishes, the second job will be running. So it will read the omniture sales data, the raw data, sales data, and it will read this process data. From the process data, it will get the modified timestamp. And from here, it will also get the user ID. Modified timestamp and user ID. Because we have to match it to the same, we have to convert the sales user ID and timestamp also to the same processed user ID and the timestamp. As I said earlier, again, these two data are a different data. We are just trying to make it a same data. So sales data should also have, we have to adjust sales timestamp to same as your new 2017, which is and also adjust modify user ID, because this user ID is different, this user ID is different, sales user ID is different, Omniture user ID is different. So we have to make sure that we have the common user ID. So we take the user ID from here and we modify it. So this is the processing that we are doing, so that both look like they are coming from the same company. Finally save it to create one more table called sales, create one more table called sales under the process DB and save it. That we will see in the next session. Once we have that, our next job will be running. Once we have that, we'll be having our Spark job 3, which will read from this table and from this table and map sales to session. How many sales did happen in a particular session? All those mapping will be done by this job 3. So as you can see, first job 1 has to run, then job 2 has to run. As soon as job 1 completes, because job 2 depends on the Omniture data, processed Omniture data. So it will pick the processed Omniture data. Once the job 2 is finished, it will write the sales data to the processed DB. And job 3 depends on these two data, Omniture processed table and sales also processed table. It depends on these two tables, and we read it from there and we get it. So one after the other, again this job 1 depends on Hive partition. Only after doing the partition you can run the Spark job. So there is a dependency. So first Hive job partition will run, then the Spark job 1 will run, then the Spark job 2 will run, then the Spark job 3 will run. So I hope this part was clear. We are done with these two. Tomorrow we'll see the other job. So let's wind up the session here and let's continue tomorrow. Thanks everybody. Have a nice day and good night others. Yes, Anand. If you could also, if you could share some sample data, that will also be very helpful. I will check. Okay, okay. Yeah. Thanks everybody.